Angular Hungary. I fluently speak Hungarian. I did not tell it anyone, but I fluently speak Hungarian, at least when it comes to cursing. And there is a funny story, namely in high school back then, we had a class with people from Hungary. Our high school was not far away from the border, and we had sports education together. And of course, we Austrians cursed in German if we failed the goal, and the Hungarian colleagues cursed in Hungarian. And so we learned from each other fluently cursing in this or that language. But besides this, I will, I think, stick with English for the time being. So yeah, let's get started with this very presentation here, with Angular's future. And I want to start with traveling in time. Namely, I want to travel back to October 23rd, 2013. Do you remember what you did there? Well, I perfectly remember, because this was the day on which Angular 2 was announced. Back then, it was called Angular 2, and it was announced in Paris at NgEurope, which was back then one of the hugest international Angular conferences. And the main theme of this presentation was, we need to rethink old habits. In German, they say we need to cut away all, pigtails, plates, because the web evolved. This was the main theme there. And at the summary of this presentation, they showed us that we won't need a lot of concepts of AngularJS anymore, because they are outdated. Because we need to remove those old pigtails, we can go on with components in Angular 2 and ECMAScript 2015 and so on and so forth. And they even presented us one gravestone per concept that did not make it into Angular 2, like controllers or the directive description object or $scope. They told us we don't need it because we have no components in Angular. Or they told us we don't need jQuery or jQuery Lite because the DOM has evolved and it's safe to use DOM in the same way in each and every browser. And another gravestone was for Angular modules. They told us, hey, we don't need it because ECMAScript 2015 will have its own module system. And having two module systems side by side does not make a lot of sense. Yeah, this was more or less the summary of this. And then they started implementing Angular. And I remember in Feb 2016, I already did Angular workshops on a regular basis. I did workshops for huge companies that have been early adopters for Angular. And in this workshop, I found it on my GitHub profile. I used this code block. I used this app class. And as you see here, this app class did not need any modules because we could assign the context, the so-called compilation context of the component directly to the decorator here. That meant we needed to tell the component what it is allowed to call. For instance, directives like ngIf or ngFor, or another component, or a bunch of router directives like router outlet, router link. But you also see here, it was kind of annoying, wasn't it? It was really kind of annoying that we had to directly define all those relationships, those elements from the neighborhood of the component in this very option. And that's why people started to put things that go together into arrays, like the array router directives, which was kind of a replacement for a module, a box with stuff that is usually used together. This was in Feb 2016. In August 2016, we got RC5, which was one of the last release candidates for Angular 2, as it was still called back then. And RC5 introduced, perhaps we could call it a breaking change. They introduced modules, NgModules. And this allowed us to define the context of the declarations in here of the components within one central place. And that was not a bad thing in general, because we've seen before, if we need to define something like this on a component basis, then it's really exhausting. But on the other side, this introduced another drawback. Namely, we had the compilation context, but in order to get it, we now had two module systems, the TypeScript module system and the Angular module system. And especially for beginners, it was difficult to grasp the difference. It was difficult to grasp it for beginners. And even for people that work with it on a regular basis, it is kind of annoying that we need this further building block in between the components. I remember some years later, Ivy arrived, and at NGConf 2020, I did a talk on Ivy. And there I explained that after the compilation done with Ivy, we don't see any NgModules anymore. We have NgModules before the compilation, but not after it, because the Ivy compiler puts the compilation context of a component into a static property of the component. So if you look here, our component is called dashboard tile component, and it has a static property which is called directives. And here, or to be more precise, it's called component.directives. And here we can put the metadata of all the other components that are in the neighborhoods that we can call from within our template. That means after compilation at runtime, there are no NgModules. However, this only was the case after the compilation. This all is part of the private API of Angular. And back then I already said, well, now it's just a matter of time until this feature will be placed somehow in the public API of Angular, in the part of Angular we are all allowed to use. And meanwhile, this is the case. There is a design document that is specifying how to make use of this feature in the public Angular API. And this design document that is currently under development, hopefully it arrives this year. This design document tells us that we can define that a component is a standalone component. We just need to turn the switch. We just need to switch standalone to true. And if we do this, we can directly define the neighborhood of the component, the compilation context, using this imports array. We can import other standalone components, like here the home component or the about component, and we can also import existing modules. This is vital because we need to be backwards compatible with existing source code. The Angular community is quite huge. There are a lot of libraries out there, and it is really necessary to be capable of using these libraries also together with standalone components. So to put it in a nutshell, we can import both components and modules. And by the way, we can also, like in React, bootstrap a sole component. Just call a method like this, pass your component, and that's it. That means we don't need to have this app module with the bootstrap array. One less indirection. This all looks great, but when we have dealt with those details, two questions will come up. Namely, what does this mean for the compatibility with existing libraries and existing code? Do I need to migrate my existing code, for instance, or can existing code work together with standalone components? And the second question is, what does that mean for my architecture? How can I structure a huge Angular application without NgModules? And those are exactly the questions I want to answer here in this presentation. For this, I've prepared several things. I want to get started with the Manfred model of standalone components. The Manfred model, which tells us how we can think about standalone components. Then we will go on with compatibility. What can we do to make sure that everything works seamlessly with existing source code? And I will tell you something about your architecture, about your possible future architecture, how you can substructure a huge application without NgModules. Perhaps we even find out that there are better ways of doing it. But before I start, let me tell you something about myself. I am Manfred. I am a trainer and consultant for Angular, and I'm really focusing on Angular for enterprise scale development. For this, I'm doing a lot of consultancy workshops and trainings with companies. Besides this, I'm quite connected with the Angular community. I live in Austria. I do a lot of stuff in Germany. And I'm always happy if I can work together with people around the world, for instance, with people in Hungary. Nowadays, everything is done remotely, which really works well. I was surprised how well remote workshop works. Okay, let's get started with the first chapter, with the Manfred model of Angular and standalone components. You can, in general, imagine that a standalone component is nothing else than a traditional component with an NgModule of its own. It just gets its NgModule. At least this is the Manfred model. It's not implemented that way, but you can think about it that way, and this will help you to deal with some challenges. That means when you see something like this, a standalone component, standalone true, and some imports, you can just compile this in your head into a structure like this one here. Into one NgModule that is declaring this component, that is declaring the compilation context, the neighborhood, that is importing further modules into this compilation context. Plus a traditional component, as mentioned before. By the way, besides standalone components, there are also standalone pipes, because otherwise you needed NgModules for declaring a pipe. Just set standalone to true for them. And there is something that's called standalone directives. That means we really don't need NgModules anymore in the future. They will stick around because everything else would be a breaking change, and the Angular community did not make the best experiences with breaking changes, to be honest, but you don't need to use them. It's up to you if you use them or if you skip them. By the way, and we've seen this before, you can import standalone blocks into your standalone component. You see it here. Here I'm saying, well, this standalone component wants to use this further flight card component and this pipe and this directive, which acts as a validator. And this brings me to my wish list. I know I just had Christmas and Christmas is over, but nevertheless, I have a short wish list for standalone building blocks, as I call it. And one of them is we need auto imports for those standalone blocks in the template. because defining all this stuff by hand is really exhausting. No, this is not fun. We want to have this in some automated fashion, like an auto import for imports, exports in TypeScript. And I already wrote a click dummy for this. This here is my click dummy, my prototype. Let's imagine we are typing something like this into our template. I'm using this standalone component and I'm using ngIf. If we do something, then immediately one thing should occur, namely Clippy needs to arrive. I think we really need Clippy for this. It won't work without Clippy. And Clippy is telling us, hey, it looks like you want to use an ngIf directive and my component. Shall I import it to you into the imports array of the standalone component? I mean, we have something like this currently in IDEs like WebStorm, where some mechanism is asking us if we want to import this or that module. Now we should do the same on the level of standalone building blocks. And yeah, you are right. We don't need Clippy for this. It could also be this blue circle that occurs, for instance, in Studio Code. Okay, enough for the theory. Let me show you a bit about this using an example. For this example, I'm using a shim. This shim was provided by the Angular team, and obviously it's not intended for production usage. It's more intended for playing around with it to get a feeling for this future development within Angular. Okay, let's have a look into it. So this example is my workshop example. It's a quite simple one. I always say when it comes to workshops, examples should be as simple as possible, but as difficult, as huge as needed to show all the concepts. And this is also the case here. I can navigate to this route, and then I can search for some flights, for instance, from Graz, which is the city I live in, to Hamburg. Hamburg is a very nice city. It's always worth a trip, if you ask me. This is my example application. And this application was completely developed without NgModules. I'm just going with standalone building blocks in there. Thanks to the shim, this is possible. So let's have a look here. Here you see that I have an app component. And this app component is standalone, which means it does not need any NgModule to live. And because it does not have an own NgModule, we need to define the compilation context. This and that component, even this and that module, we can even call for root, which is totally fine. And this shows the beauty of the Mantel model of the standalone components. Because of this Mantel model, because of those decisions, we can use existing code without any issues. Of course, there are always ways to streamline existing libraries a bit to make it even more easy, but more or less everything works here because a standalone block can be seen as a block, a component, a directive, a pipe with a module of its own. Besides this, if you look into my example, there are no NgModules, just building blocks, which really makes it lean, doesn't it? And there is this main file where I'm directly bootstrapping this component here. No NgModule, no bootstrap array anymore. How cool is that? Okay, now the next question is, what's with compatibility? How can we make sure our investments are safe, our investments of the past? Well, as mentioned before, the good message is you can directly import modules into a standalone block, like HTTP client module or the router module. This is not a big deal, and so you can reuse existing source code. However, what's with the other way around? What's in cases where we implement newer stuff with standalone components and older stuff with NgModules? Well, in those cases, you can directly import a standalone component into an NgModule. That means your new stuff can be used with existing code, which is also quite nice and which is also possible because of the Mandel model. When I saw this first, I thought, well, importing a component is somehow weird, isn't it? Because normally components are not imported. This is a rookie mistake to try to import a component. No, normally components are declared. However, declaring a component means that the component belongs to this NgModule, and only to this NgModule. It is not allowed to declare one component with different NgModules. However, if you think on the Mandel model, where a standalone component is just a component with its NgModule of its own, then this suddenly makes sense. Then it makes sense that we can import this standalone building block. It does not belong here, but it can be used here. And this also brings me back to my wish list, even though Christmas is already over. The second part or entry for my wish list is we need to update our schematics. Because currently several schematics out there don't work with standalone components. Those schematics normally look up the root module. They look into the main TS and then they look up the root module to register this or that further module with it. But now there is no root module anymore. And so we at least need a switch for those existing schematics. I also run into this when I updated my example for Angular Material and NgRx. Okay, let's have a look into this. For this demonstration, I will migrate my application to Angular Material. Perhaps this is the fastest migration to Angular Material. Let's click here. Let's switch over and hocus pocus. Yeah, here it is. It's really that easy. And yeah, as you see here, it's totally fine to use my standalone components together with this pre-existing library, Angular Material. Here we have some tickets, here we have some flights, and so on and so forth. And if we look into my app component, we even see that I'm not just importing Angular Material, but I'm also importing NgRx. And also, one more time, we see that this is kind of annoying, isn't it? It's kind of annoying that we need to import 5, 6, 7, 8 or more modules into our standalone blocks. That means we need a better story for this, but I've got you covered. We will come to this when we switch to architecture. Okay, this shows that we can use existing source code. And now let's move over to a piece of existing source code, namely tickets. Here I have an NgModule. And here you see I can import my flight card component here. I can import it here and make use of it. Okay, the full truth is I'm not directly importing it, but this is just because of the shim. So if we don't need the shim anymore, if we get this as part of Angular, we don't need this extra line. But I also think this extra line is worth 1 or 2 sentences because it shows how the shim works. Namely, the shim is creating a module of its own for this component in this property. And of course, the compiler wants to have a module here. So let's give it this very module. That's more or less all we need to respect. As mentioned before, this is the Mandel model. It's not implemented that way. And this line will go away when this feature lands in Angular. Okay, so we have seen it works in both directions, which is kind of nice and also kind of necessary, if you ask me. Okay, now let's come to the most exciting part, to the architecture part. How can we structure a huge application without having NgModules? Well, and the easiest answer is we just need a folder. Just structure your application with folders, one folder per feature, for instance. Here I have a flight booking folder for my flight booking feature. All the components that belong to it go in here. However, sometimes it's also nice to substructure and to group things belonging together. Components you usually use together. And for this, you could go with a barrel. And a barrel is nothing else than an index.ts. Some people also call it public API.ts. And this file is re-exporting all the things belonging together. All the things that are usually used together. And the thing is, this barrel gives us several advantages. One advantage here is it groups things belonging together. We've already had this. Another advantage is, and you see it here, the barrel is your public API. That means if you expose everything via the barrel, other parts of the applications are allowed to use, you have something like a public API. Everything exported here can be used by other parts of the application. Everything not exported here is your little tiny secret. Your little tiny secret. And trust me, it's good to have secrets. It's one of the ways for building a stable architecture. Because everything you keep a secret, for instance, the passenger search component, can be changed afterwards. Everything that's your secret can be changed, can be broken without breaking other stuff more or less. But everything that is exposed here needs to be backwards compatible somehow in order to prevent to break other parts of your application. Go with public APIs. It makes your architecture more stable. Saying this, unfortunately, in JavaScript, it's always possible to bypass your barrel. No one can force existing code to use the barrel. The existing code can directly sneak in here to the folder and reference something from over there. However, as we will see in some minutes, there are ways to prevent this. There are ways to prevent access to, let's call it, private building blocks. Also, we can sooner or later also import a whole barrel, which could look like this here. We can import the whole barrel with import asterisks, and then we can reference it here in the import section of our standalone building block. Currently, we need this little trick here. We need to take the, not keys, but values. I'm very sorry for this. Let me correct this. The values from my exported module. You know, if you are importing or exporting something, you get a key value map. The keys are the names of the exported building blocks, and the values are the exporting building blocks themselves. And here I want to have all the values exposed via booking. Yeah, here it's right values. However, this is not beautiful, isn't it? If you have to use a construct like this is everything but beautiful. And of course, you can write a helper method to make this a bit more streamlined like this. I've written a helper method called all, but it's also not the last word on this, if you ask me. If you ask me what we really need, besides having such custom helper functions, is a better syntax for importing whole barrels. And there are discussions about this. Some people on the Angular team already told us that it would be smart to implement something like this. It should not be difficult, I guess, but it will help us to import a lot of stuff that belongs together. Like, I don't know, data table with data row and data column, something that is usually used together, I guess. Okay, now we have a huge achievement, because with all of the things I've shown you so far, we achieved to just go with TypeScript modules, with TypeScript imports, exports. And this makes everything more straightforward. It is lowering the entry barrier for new developers, and it makes everything more straightforward. We only need to have one module system in our mind. Quite nice, isn't it? However, we can do it a bit more nice, a bit nicer. For instance, we could go with path mappings. We could assign beautiful names to our barrels, like project name data, or project name shared, shell, or booking, this feature, that feature. You can do this in your dsconfig file. And if you've done that, then you can directly import stuff using this beautiful map name. You don't need such relative paths anymore. Things like ... /... I also call this the Vienna Waltz style. No, we don't have any Vienna Waltz anymore. We just go with beautiful names. And the best of this is, this even looks like the name of an imported NPM package. It is not an NPM package, but it looks exactly the same, like Angular Core, Angular Common, which is also quite a nice thing. Okay, let's have a look into a demonstration for this. For this, let's switch over here. Let's go into my barrel. Yeah, force checking out. Yeah, it's fine. And now we see that each and every folder has this index.ts, like the shared folder has an index.ts exporting the public API of the shared stuff. The same is true for booking. Here we have an index.ts, and the same holds true for my shell, which is exporting the navigation bar and the sidebar. And if we look into my app component one more time, we see that here I can import all the values from the shell. And by the way, I did something similar for Angular material to prevent the need for importing all the, I don't know, 8 material modules I need here or there time and again. If we scroll up, for the shell, I'm also using a pretty map name. And as mentioned before, we need to streamline this a bit because this syntax is everything but beautiful. I've written this helper method, yeah, which is a good start. But sooner or later, we need direct syntax support from the Angular team to make something like this possible, if you ask me. The compiler is eating it, but it won't work here. Okay. Awesome. So now if we talk about architecture, the next logical step would be to move to a workspace, to a monorepo-based workspace. And for this, there is a beautiful tool out there called NX. NX helps you to subdivide a huge application using libraries of a monorepo. If you go with NX, you can create several libraries in your application, in your workspace. For instance, one library for the booking feature, or one library for the domain logic of booking. You know, all the entities you need, at least your client-side perspective to your entities, like, let's say, a flight or a ticket or a passenger, and only services and also services operating on them. Or you could create a library with general UI stuff for dealing with cities, this airport, that airport, or a UI library for your shell. This gives you a clear structure. You have a lot of libraries in your huge application, in your huge workspace. NX, by the way, gives you some additional features like this here. You can visualize the structure of your application. That means you can easily find out which part of the application is using which other parts, which application is using which libraries, and which libraries are using which further libraries. And this is vital, especially if it comes to a huge project. This is really vital, because on a huge project, you need to have the overview. That's the first thing. And the second thing is, this allows you to find out if things are too tightly coupled to each other. You don't want to intermingle everything with each else. And using this, you can prevent such a situation where everything depends on everything else, which will lead, of course, to an application that's not maintainable anymore. By the way, there are also further features, like the path mappings for the beautiful names are generated for you. You don't need to tinker them by hand. You get an initial barrel, which is called index.ts. And there is even a linting rule that allows you to bypass your index.ts. We've discussed it before. The index.ts is your public API. You can only access what's imported via this file. However, TypeScript and also JavaScript in general allows you to sneak into the private areas of this part of the application to reference something from here. And this is something you can prevent. There is a linting rule in NX that tells you, well, this is not allowed. Please go with the barrel. Go with the beautiful name and don't sneak into this private room. Nothing for you. And there are much more features. Features like this here. You can define which library is allowed to access which further libraries. For instance, if you look here, I'm in my navigation bar, navbar, and I try to access a feature. That means a general purpose component tries to access a very concrete component, a component implementing a concrete use case. And in my case, this is forbidden. I've configured NX so that NX shows me a linting error when I try to access something I'm not allowed to access. And here, besides this German warning, I get this error message in English, which tells me, hey, you have a project tagged with UI. I've told NX, well, navbar is a so-called UI library. And here, according to my rules, an UI library is only allowed to access libraries of those categories, but no feature library like this here. This is really beautiful because this allows you to enforce your architecture. It allows you to prevent coupling from the beginning. No broken windows anymore. If you go down this road, then my colleagues, but also the NX team is recommending something like this. We are all recommending to use those libraries to subdivide a huge application according to 2 dimensions. The first dimension, the vertical one, is about business domains. Areas of your business that are reflected in your application. When it comes to airports and flight booking, we have a booking business domain, a boarding business domain, perhaps a check-in and a luggage business domain. And then there is a vertical with shared stuff we need to use everywhere. And besides those verticals, we also have several rows, and each row contains several libraries, quite fine-grained libraries tinkered with NX. Here, for instance, we have feature libraries. Feature libraries contain smart components. You know, smart components are components that know your use cases. They know what to do to help the user to achieve a specific goal, like booking tickets for a flight to Hamburg. UI libraries contain dump components, which are components that don't know about your use cases, and that's why they are super reusable. Think on a date time picker. It does not know about your use case, and that's why it's super reusable. Or think on an address component that has been created to display addresses time and again in different use cases in a similar way. Those address components don't know the use cases, but they are called by several use cases dealing with addresses. You need this distinction in order to get reusable components. Besides this, we have here a domain layer with domain libraries. This is where your data model is found, your client-side perspective to your entities. Here we have a ticket interface. Here we have a passenger interface, a flight interface, and of course, services operating on them, loading them, storing them, validating them, calculating something. Of course, most of the business logic is in the backend, but sometimes we need to do tiny calculations in the front end or even delegate to the backend. This all is located here. Yeah, and utility libraries are for general purpose utility stuff, like converting dates into strings, or for authentication or general purpose validation, logging, stuff like this. So the good thing here is this idea gives our application a nice structure. There is less discussion about what goes where and what is found where. We cannot afford discussions like those in a huge project. No, we just want to know where to find something, where to put something. This is one of the advantages. Another advantage is, thanks to those access restrictions we've seen before, those boundaries, we can use this structure to enforce an architecture, but also to enforce loosely coupling. For instance, I could say, well, one layer is only allowed to access layers below, and one domain is only allowed to use its own stuff and shared stuff. Perhaps the later one is the more important aspect and access restriction. Booking can only deal with booking stuff and shared stuff. Boarding can only deal with boarding stuff and shared stuff, but booking and boarding cannot directly interact with each other because this would cause a tightly coupled situation that is not maintainable, of course, in the long run. If you violate these rules, then you get a linting error like this here. Okay, let me show you an example for this. For this, I'm switching over to another workspace. It's the same project, but now it's part of an NX workspace. And if we look here, this NX workspace has several libraries. And the libraries are first of all subdivided into business domains. Business domains that reflect areas of the real world your software is for. Boarding, booking, check-in, and here we have the shared area with general purpose libraries. If we drill in here, we see that we have several libraries per domain, and the prefix of those libraries shows you to which layer this or that library belongs to. Here we see, well, this library is part of the domain layer. Those libraries are part of the feature layer. And here we have dump components that are part of the UI layer. That means just by looking at the folder, you know the domain, the vertical. Just by looking at the prefix, you know about the layer. If we drill in here, we see source code, general purpose Angular source code, like a flight booking component, which is in my case a standalone component with several imports. And we have the barrel here. The barrel that is defining the public API, everything other libraries of my system are allowed to see. Everything else is my little tiny secret. And by the way, in order to access another library, we are just using its map name, like here. It's beautiful map name, and this map name is also created for us by NX. So at the end of the day, we end up with quite tiny NgModules, no NgModules, with quite tiny libraries, and they are the perfect replacement for an NgModule, if you ask me. We can create a dependency graph. Now, let's cross fingers. Here it is, my dependency graph, show all, which shows how everything is structured here. Perhaps I'm putting away the shim, then it's a bit more straightforward. Yeah. Then you see how my building block access layers below. Okay. However, here we also see somehow this is not allowed, isn't it? Here a UI library is accessing a feature library. That's a mistake. Let's look what NX says about this. Let's move to shared UI shell. Shared UI shell. Here I have my navbar, and when we look into it, yeah, we see it was my mistake. I did a mistake for some reason, perhaps it was just an auto import. I created this line. And because of my rules, something like this is not allowed. I'm not allowed to access features from within dump components. And that's why I get this error message. How cool is that? No broken windows anymore. But it's even better. I mean, having this here while typing is quite nice for me because it's immediate feedback. But we can also get this error message when linting this library. Let's say I want to lint shared UI shell. And then I should get the very same error message. Come on, run, Forest. And yeah, here we have it, the very, very same error message on the console. I'm part of the UI layer and I'm only allowed to use this or that, but not the feature. And this is even better because this allows us to automate this check. Everything that works on the console can be automated. That means we can define this as one of the checks before it's allowed to merge source code into your main branch. Besides checking for unit tests, integration tests, we can also check for those rules. And that means if someone is breaking our architecture, our nice matrix, then they are not even allowed to merge the source code into our code base. No broken windows anymore. By the way, if you like those ideas, then you will very likely like our free ebook. You can download it here, Angular Architects.io/book. And if you don't like those ideas, download it anyway. Perhaps it's useful anyway for you. Angular Architects.io/book. Okay, now I want to show you one bonus chapter I've prepared for you. It's about how to prepare for a migration to standalone blocks. For this, I have identified several strategies. And the first strategy is a funny one. Perhaps you know this special bird here, the ostrich. And that's why I've called this the Ostrich Strategy. Just put your head into the sand and do nothing. If there is something that's dangerous, put your head into the sand, you know, like a 1-year-old that thinks that if he cannot see anything, they cannot see him. And this is totally fine. I know it's funny, even though because of the picture, or especially because of the picture, but this is totally fine because standalone components are just an option. You don't need to go with them. NgModules will stay here. They won't go away, because if they went away, that would be a breaking change. And this is nothing that's intended. So it's totally fine to keep with NgModules if you really love them, or if your project is almost done. First strategy. Second strategy, remove NgModules and go with direct imports. Directly import the context into your imports array. Hopefully you remember my wish list. We will get auto imports for this. Another option would be to go with barrels and perhaps with path mappings. We've just seen this before. In those cases, you could replace your NgModules with barrels. And the fourth option is, and I think this is the best option for a huge application, to go with libraries. Replace your NgModules with fine-grained libraries in a mono repository. And for this, I have a little tiny thought experiment for you. Let's imagine this is a part of your mono repo. You have it already nowadays. There is a library in there with a feature or something else, and there you have two components. Currently, you have this NgModule because currently we need it, and this NgModule is part of the public API. That's why it's exposed via the index.ts. If we have another library, then currently with NgModules, we need to reference the module from over there. And for this, we need to go via the index.ts. And you see it here when you look at the arrows. This is everything but logical. There is no arrow from here to there. But anyway, component 3 can now access component 1 and 2. So somehow this is not that logical. However, if you have a structure like this, and this is really a typical structure when it comes to NX and huge projects that are subdivided using libraries, then everything you need to do is to remove your NgModules and directly go via your public API, via your index.ts. And I think this looks far more logical, and it's really leaner. Directly accessing stuff from over there via this gatekeeper here, via this public API. That means if you start today with a huge project, I would recommend to go down this road, and it will be quite easy to migrate to standalone components a bit later. Actually, this is the story we are telling for years, because we always had standalone components in our mind. Okay, so little tiny information. If you like all those ideas, there is an Angular architecture workshop coming up. You find details about it on this URL. And we are also doing a security workshop and a professional testing workshop quite soon. So if you want to learn more about this, then check this out. Okay, let me come to a conclusion. What did we see today? Well, we've seen that the Manfred model of standalone building blocks is really beautiful. The Manfred model is we have a building block with a module of its own. And while this is simple, it's also quite effective because this is the key for backwards compatibility. In order to substructure our application, we can go with folders and barrels. We can even go with mapped paths. All of them are good replacements for NgModules. And also, the next logical step would be to go with NX, with libraries, and of course, with constraints between those libraries so that you can enforce a loosely coupled architecture. Now you have the best of both worlds. You have the loosely coupled architecture provided by NX, and you have the lightweight solution provided because you will go with standalone building blocks. And to finish, I just need someone who is capable of changing a gravestone, you know, with a hammer and this other tool, because now we need to change the date here from 2014 to 2022. I really believe that 2022 is the year where we can put back Angular modules to the graveyard. It was kind of a zombie. It was already dead, declared dead in Paris, 2014, and now it will return to the graveyard, you know, the walking dead. And that's it. So thanks for having me. Here you have my contact data. I will upload all my material to my blog in some minutes, and follow me on Twitter to stay in contact. Thanks for this.
Thank you very much. Meanwhile, we had 6 questions, so I just start to share my screen to show you all the questions.
Pleasure.
Just a moment, it's coming.
Mm-hmm.
Yeah, hopefully you see it. So the first question was the most upvoted with 4 votes. Lazy load. Every standalone component imports the same pipe. Will the size of project increase? I mean, every JS file will contain the source code of that pipe.
The good answer is the size will not be increased. There are even some experiments showing that perhaps the bundle sizes will decrease, but at least they will stay the same. And this is mostly because of the CLI and Webpack. It's already the case today. If one portion of source code is used in several parts, then Webpack puts it into a bundle of its own, or Webpack loads it up front. It a bit depends on the size of the shared stuff.
Okay. Then I would say the question was answered. The next one. So is it some kind of microarchitecture for Angular? I mean, now one person can work on one component without touching any part of the code.
Yeah, normally for a micro frontend architecture, you have a bit more of decoupling, like working in separate repositories or working in one repository with access restrictions, like seen here. So technically, this does not really help with micro frontend architectures, but at least it makes everything a bit leaner.
Thank you. The next one. If we import modules into the component, not the module, is the result can be smaller?
There are some experiments that show that the result can be smaller, if we directly import other building blocks, not modules, and experiments showing that the compilation is a bit faster, because now the dependencies are more direct. The compiler does not need to go around the corner.
Thank you. The standalone components is a better way of implementing the shared part of code, or it is another purpose?
Well, we will see. We will see. In my opinion, yes. In my opinion, it's the go-to solution for the future because it makes everything more lean. And if we look to other frameworks like Vue or React, there we have a similar situation. They don't have a module system of their own. They directly import stuff from other libraries, components, and other stuff. Some people think that at least for NPM packages, NgModules will still be valuable. I'm not quite sure about this. I will try hard to prevent them in general. It makes everything leaner.
Thank you.
So the answer is yes. In my opinion, yes, but time will show.
Will there be any new unit testing APIs to mock standalone components? Can they be mocked with declarations in a testbed module?
Yeah, I'm quite sure that they will streamline the existing API. I mean, the good message is everything immediately works with standalone components because of the Mandel model. That means we could import a standalone component into the testbed module, and so everything works. But they also told us that they plan to streamline some APIs. And I'm quite sure one candidate of this should be the testing story. One helper method here, one helper method there. Another candidate for the streamlining they already mentioned is the router. It works perfectly, but it can be a bit nicer in terms of API calls to use the router with standalone stuff.
Thank you very much. And the last one, could you use an array function to flatten instead of spread? I suppose it still isn't nice syntax.
I think currently that's not supported. They don't want to have it because they told us if we allow to import arrays like it was the case in Angular 2 beta, then you will write your own modules, namely array-based modules. And they don't want us to do this. Instead of this, they want to push us towards web standards. And one of those standard-based solutions is the Barrel. You know, it's more or less part of ECMAScript. It's heavily used out there. And that's why the idea is to rather give us the opportunity to import whole barrels.
Thank you very much. Meanwhile, we got one more question. Adding components to an index TS seems a repetitive task. Would be nice for the wish list.
Yeah. It really is. It really is. I think in a perfect world, it would look a bit like in .NET. In .NET, you have an own access modifier for stuff that is seen outside of your compilation unit of your assembly. We don't have something like this in ECMAScript, and we have kind of the same situation in Java. However, since Java has its own module system, it looks like barrels in JavaScript. And yeah, you can automate this. There are already today Visual Studio Code plugins that automate this. Of course, they export everything, and then it's your task to define what should be part of the public API.
Thank you.
That means you need to throw out everything that's your little tiny secret.
Is the spread technique for imports not risky? The spread operator can override other components with the same name.
Yeah. This is one issue for sure. However, I've also seen that some people use this on purpose in order to tweak the application one code base which is used to compile out this or that application, this or that version of the application. And then they are using something like shadowing. You know, if you have several customers with different needs, this is one option, tweaking it on compilation time. Another option would be to tweak it on runtime, and both has its very own advantages and disadvantages. But yes, that would be possible if you ask me.
Thank you very much. And I think this was the very last question. So thanks for the presentation. I think it was great and we learned a lot. It's pretty useful to get prepared in the future so early. So actually, meanwhile, I just realized that I forgot something, because I prepared a set of questions for the audience and I totally forgot to start this vote. So if you don't mind, then I will start it now. There are just a couple of basic questions like, where are you right now? Are you in Hungary or not? How much experience do you have with Angular, and such questions? I will just launch it, and I think you will be able to see it right now in Zoom. And meanwhile, I'm also seeing how many people completed these 4 simple questions. There are, okay, quite many, 13, 16, 18, 19, 22, 24. It's rolling up pretty fast. And of course, in the end, I will show the results, so you will be able to see how much experience we have, where are we from, and such things. Okay, so we have 34 answers. That's okay, 36, 38. That's 80% participation rate. It's quite good. So I would say then I just end the poll and show you the results. I don't want to waste your time. And now I'm clicking on the result. So let's analyze it together. From Hungary, actually, the majority is not from Hungary. Very interesting. Are you visiting us for the first time? Actually, yeah, most of the visitors, so 3/4 of the audience is here for the first time. Have you Zoomed before? Yes. Okay, that's cool. Good to know. Then I shouldn't educate anybody how to use it. However, you know Angular, very interesting. We also have quite many beginners, advanced, intermediate, so it's very interesting. Okay, thanks, thanks. Good to hear that the Zoom tips were not useless. Then I would say I will continue with micro frontends with my presentation. So we will talk about micro frontends and especially about Angular Elements, which is a library from Angular, which makes it pretty easy to create web components and custom elements from your Angular, regular Angular components. Before we get started, let me tell a couple of words about me. My name is Marcell. I'm working as a full-time front-end contractor, basically working in the kind of a very big company. It's an enterprise in FinTech industry. And you can also see 2 very beautiful cities on the left and on the right side. I added this to the slide because these are the most important cities. They are playing a very important role in my life. I was born in Budapest and I was also studying in Budapest, and just after getting my diploma, I moved to the other beautiful city on the right, which is Hamburg in Germany. And I was living there for almost 2 years. Then I moved back to Budapest, and later on in about 2018, I moved to Hamburg again. And since 2020, I'm here in Budapest again. You can find me on GitHub, you can find me on Twitter. So I would say, let's get started. I divided this presentation into 3 parts. In the first part, we will cover the project itself, how the team looked like, what was our goal, how was the architecture built up, and such general topics, just as warm up, I would say. In the second part, we will talk about micro frontends in general. What are they? What are the goals? What are the motivations? What are the benefits? And what are the challenges on the other side? And in the last part, we will get into some very exact details now, how you can use Angular elements to get started creating web components. I did my best to keep all the slides as simple as possible, so you won't see too many images and stuff. On the other hand, I will talk quite a lot. I hope everything will make sense and you will find it useful. Let's get started with the project. For a project, we always need a team. The question is, how does the team look like? How big is it? And how is it structured? We started with a team like this. This is a very basic cross-functional team where we have a dedicated person for each different role. Of course, it can be a bit different. Maybe you have not just one business analyst, but 3 of them. Maybe you have a dedicated UX researcher, and maybe you have multiple front-end and back-end developers separated. But the most important thing, this is kind of a small interdisciplinary team responsible for many aspects. And that's why it's agile, because the communication should happen very, very intensive. A bit about the product, what we had to build. What we had to build was actually kind of, I would say it was a client portal, a change portal, where the client of this company was able to change his data like address, payment method, or search settings. This is actually a very abstract representation of the real story, which I was working on in the last about 2 years. But you can imagine a web shop, for example, where more or less you always have these options that you can change this data. And what for us at this moment, the most important thing is that let's imagine that all these topics are completely independent from each other. If you change your search settings, it shouldn't affect anything on the other domains. So they are very clearly separated. About the architecture, what we see is actually 3 horizontal layers. It's beginning on the top with the business services, where we store the business logic. And the business logic was separated for the 3 different domains from the very beginning. What you see in the middle is the interaction service, which is basically combining and reformatting sometimes the responses from the business services and finally sends it back to the front end. It's basically a method to isolate the business logic from the front end, because here, you can be a bit more abstract and you can combine different responses and stuff like that. What for us important is front end was one project. That means it was one repository with one build process, with one host, with one deployment pipeline, although we have seen clearly at the beginning that we have 3 very different domains. This is why we were using NX. Actually, Manfred did a very good introduction what NX is all about. As you can read, it's a smart, fast, extensible build system, and why we also really liked it, because it's pretty easy to create multiple applications in the same repository and create multiple libraries. This is also how you can isolate your different domains and make it sure that your dependencies are just fine, and you are building not a monolith, although you are in one repository, but still you are building a modular application. And this will play a pretty big role in the future. This is what we also see on the right side. Change portal is the big portal, the main application, which we want to deploy to the host in the end. And this change portal is using the 3 domain libraries, address, payment, search, And there is also a fourth library, which is called shared, where we can store all the shared functionalities, services, and components, which are so general that they are also used from multiple other domains. Okay, let's see an exact example. What did the client see? When the client visited this page, this change portal, then he was seeing a couple of cards with a couple of options, like you have seen a card maybe with an icon that you can change your address if you click here, you can change your payment method if you click here, and so on. As soon as the client clicked on the change address, the client landed in a flow, in the address change flow, and everything that belongs to this flow was implemented in this address library. So it was pretty fine separated from every other topics. On the first screen, for example, you can enter your data, you can click on continue. On the second side, you can review your data and decide to go back and correct some stuff, where you just say, okay, everything's fine, I want to save this. And on the final screen, you see that, okay, everything went fine, you saved it. Actually, we really implemented this flow. It was working fine, everybody was happy. And later on, the enterprise realized that there are also other applications which are implementing the same functionality. And of course, it's pretty redundant. It's not that cool. So it would be cool if we could, centralize it. One example was the mobile application. The mobile application was built using Ionic. What for us important from this story is that Ionic is also a browser-based, it's kind of a hybrid application. So we are still in a browser, and this is why it was not that difficult to hide that switch when we wanted to jump from the mobile application to our new web portal. And exactly to this screen where the flow starts, where the user can change his or her data. So we did an integration per URL, and what else? Maybe there is something else which was pretty important, is the authentication, because as long as you don't have the option to use single sign-on, then you will suffer. Then the user experience will be pretty bad, because as long as you want to jump to the other side, the user has to log in again, and that's pretty painful. You don't want that. On the other side, it's also very important to have the same look and feel. That means you should more or less use the same UI components also on the mobile and also on the change portal. Otherwise, the user will really experience a huge break in the flow. But we were lucky, as I said, the mobile developers were using Ionic, and they used the same UI package which we were using. So everything works fine. We could hide the details, and we integrated our portal to the mobile application. And after a couple of months, we started to talk more and more about micro frontends. At that time, the expression was pretty new for me. I found it very weird, the idea itself. Why would we do things like that? What is actually a micro frontend? But as soon as I understood the concept, I asked myself the question, was this maybe already a micro frontend, which we did here? Because the core idea behind the micro frontend is that if there is a certain application, let's call this application the host application or consumer application, like in this case, the mobile application was, and it's able to consume other front ends and integrate other front ends in a way that it will be completely independent. It's developed independent, it's maintained independently, it's deployed independently, and so on and so forth. So basically, another team is responsible for the whole domain, and still the host can use it. And actually, if you consider all these criteria was met, so this was actually a micro frontend, even we didn't know. So we were ready with the project. We developed also the other domains and the functionality also on the front end, also on the business services. Everybody was happy, and the higher level executives decided that they want to scale this project. It was a big success. So let's invite and add new teams to this setup. And every certain domain should get its own team, and they should actually work independently from each other. As you see on this image, that you see that we are still having just one common interaction service and one common front end. So it will kind of block us from being able to work independently. Even if we built up the front end in a kind of wise way using NX monorepo and modular architecture, if you have to deploy everything once, and if you are using the same build process, if you are using sharing the same branches, just one single develop for 3 different teams and for 3 different topics, it's not that cool. So this is why we decided we slice the project up like this. So from this point, we had 3 teams, and all the 3 teams were responsible for the projects from the top to the bottom, full stack from front end to the business service. And not just to the business service, basically also the other roles which we have seen earlier in the team, they were also added to the domains in an independent way. So each domain had its own product owner and UX researcher and UI designer and so on. So they were kind of, standalone projects. And with this, we arrived to micro frontends. I already mentioned what micro frontend is, but here maybe this diagram visualizes it a bit more efficiently. Let's imagine that we have a big portal where we want to show multiple different fragments at the same time, but these fragments should be developed by 100% independent teams. Let's say there is a blue team, there is a yellow team, there is a green team, and so on and so forth. And finally, the big portal does just one thing. It integrates all these little Lego or the building blocks, and it just works. The idea seems cool. Let's see what will we win with such an idea. What are the motivations? Maybe scalability is the biggest advantage, because as long as you are in one single repository in a monolith and you are adding more and more and more members, developers to this project, then you will just increase the number of dependencies. That increases the complexity, and actually not a linear way, but more like in a way that is more like exponential. This is what you don't want to do. When you feel like, okay, even if you double the size of the team, you won't be twice faster. But here with these independent fragments, if you need more fragments, you need more teams, and the teams are independent, so they will be just as fast as the others. So you can see the complexity will grow linear. Robustness is another big advantage, because as long as we are hosting all these fragments independent from each other, when something goes wrong in the pipeline, for example, in the pipeline of the yellow team, maybe in the build process, or maybe an infrastructure problem, and then the server just breaks down, the whole application, the big portal, should still be able to work just fine, although maybe this component or these fragments from the yellow team won't be available. Another huge advantage is that this solution is framework agnostic. It doesn't play any role, and it shouldn't matter which framework was used to build a certain fragment. It should be the decision of the team, and it should be isolated from all the other teams. although this sounds pretty good, in the reality, I would say you just won't jump into all different frameworks, because as long as you are at an enterprise, then the enterprise has more or less, I guess, some preferences. Like they used to work with Angular and React, for example, and maybe they don't want to introduce another third and fourth and fifth library, because then you will also have problems with recruiting. I mean, also with switching developers between different projects. They always have to learn things new. So this is why, as far as I have seen, enterprises made the decision to kind of control, strictly control the number of frameworks which can be used. We talked already quite a lot about it. These independent repositories, which be much smaller, with much less complexity. So it's much easier to get started and join a team and have an effect. You don't have to understand the whole huge monolith, just your small project. This is why these teams are able to be very specialized. Starting from the product owner to the business analysts, they are really focused on a certain topic in a certain domain. So we can expect that they are experts in this topic and they are delivering good results. So basically, as a sum up, I would say independent development, independent tests, independent deployment are all the huge advantages of micro frontends. Let's see how can we implement such micro frontends. I would start with the easiest scenario. It's build-time integration. Build-time integration is not a surprise happening during the build time. I guess you already use this method. Maybe you didn't even know that you used it. But if you used any kind of UI library, like in the Angular community, for example, Angular Material is pretty popular. If you used it, then you were kind of using a smaller kind of micro frontend, because these were such UI elements which were built 100% independent from your team and from your company, and still you were able to use it, and you integrated it per NPM during the build time. So this was a build time integration. There is also a URL-based integration. We already have seen an example at the mobile integration part. So you know this. And maybe you also notice what is the biggest disadvantage. As long as you are using a URL-based integration, you won't be able to combine and show multiple fragments on the same side. You can't really put multiple fragments next to each other. But there is iframe, and with iframe, you will be able to solve this problem, and you can show multiple fragments next to each other. Although iframe is not that performant, and you will have most probably a responsiveness problem. So this is why iframe is also not the best solution. And then I would say web components is more or less the best way which you can choose these days. I don't know whether you know web components. We will talk about them more detailed later. This is why this word is underlined. They are also called custom components, custom elements sometimes. So whenever I say custom element or web component, I refer to the same thing. And I would say that web components are not that new, because they were first introduced more than 10 years earlier in 2011, but it just wasn't ready. In 2013, Google started the well-known Polymer project, but Polymer project wasn't that popular those days. And actually in 2018, so it was just about a bit more than 3 years ago, when Firefox started to support officially web components. So that's why I would say all the web components, the idea is old, that we can really use it, and it's supported by most of the big browsers. It's something new. Regarding the approaches, there are also a couple of other options. I won't be able to cover them in this presentation, but you can Google it. But I think we covered the most important and most reasonable approaches. Let's see what are the challenges. We talked enough about the benefits. I would say performance issues. This is something you can experience because as long as all your teams are working isolated, they may say that, okay, the performance was good, my app worked just fine. But as long as you are putting 10 or 20 pieces of such applications or such components and fragments on the same page, then maybe you will experience some performance problem. So this is why it's very important to lay the guidelines right at the beginning, what is acceptable, what is not acceptable from the point of view of performance. We have the same issue with payload size. Maybe your application is not that big, it just, I don't know, 400 kilobyte, which is actually not that small, but it's just okay. But if you have 20 pieces of that, then maybe you don't want to punish your customer with such download sizes. Communication could be another, not issue, but a interesting topic. Because your fragments has to communicate with the host and your host has to be able to communicate with your fragments. The question is, how should they communicate? What kind of API will be available? I mean, from both sides. So it should be agreed at the beginning. And there is also one important topic. What happens when fragments want to communicate with each other? What happens when I'm working on a component which should react on an event which is happening in another component? Then how should I be notified about such things? This is also which requires detailed planning at the beginning. Versioning is a very interesting topic. I won't talk about that much here right now because I will have dedicated slide for versioning. But test environment is actually interesting. Just imagine when you start to develop a web component. Web component will certainly have some inputs and will certainly have some outputs. As long as you are just working on the web component, you are not really able to test it because you don't have the environment where you can change the settings for the inputs, for the outputs, and see how your web component reacts. So this is also kind of an added complexity that you will need a test environment. And actually all these stuff together, that we need performance guidelines, we need payload size guidelines, rules, and standards for the communication, versioning and stuff. This all leads to an extra high-level governance complexity, which should be taken care of. And this is the biggest disadvantage if we want to sum it up. Let's focus now on the payload size. We talked about it, that we don't want to use too much bandwidth. We don't want to download too many things at the same time. And let's see this example where we are having three different fragments or web components, we could say. And all of them are built with Angular elements. So this is why all of them are using the Angular core library and the common library. And when the big portal wants to use them, each of them has to be downloaded. That means also the Angular core and common library has to be downloaded 3 times. This is something we don't want to. This is where Webpack 5 with its module federation feature can help you, because with Webpack 5 and module federation, it's possible that you can separate the smaller parts of the dependencies, and it can be resolved in runtime and be done. And the big portal will download just the dependencies which it really need, and the Angular core library would be downloaded just one single time. And it's very important to mention, for Angular, there is a dedicated open source library which is actually initiated and maintained for Manfred. So this is also cool that he's here right now. It's called Angular Module Federation. Honestly, we didn't really use this solution or approach at the moment because we just didn't really need it yet. We didn't have such big package sizes, but the opportunity is still there. So maybe in the future, it will worth to investigate the topic. About versioning, I mentioned that we will talk a bit more detailed about versioning. Let's see how does it work. Actually, this is a very kind of utopian vision that it would be the best if the big portal would always get the latest and the greatest automatically. So that means the latest version of address change module, payment change, and search change. And yeah, actually the smaller fragments should be just deployed and the big portal could be able to consume that. For example, per URL, simply always just the latest version. That doesn't sound bad, and actually it's also possible. So why not? But let's see this scenario. We also have a design system, and all the modules are using the very same design system, and also the big portal itself using the design system. Of course, we don't want to download it 4 times because it's the same. So why would we want that? So the idea, the big portal will download the design system, which is actually a collection of web components. So very small and simple tags, which you can use when you want to use a certain component, for example, a button or an input field or something similar. This also sounds actually not that bad. We download the latest design system. We are downloading the latest fragments. What could go wrong? Actually, a breaking change, a major change, could mess up a couple of things. Let's imagine that address, payment, and search are using the 1.8.2 version. Meanwhile, the big portal is pulling the latest design system, which is 2.0. Between 2.0 and 1.x, there was a breaking change, and there are a couple of components where the API is completely changed and they just won't work anymore. And of course, this will be a big problem. And you can also imagine what happens if these teams, the blue team, the yellow team, and the magenta team, are not able to react right away, but they need a couple of days. Maybe search team doesn't have a team anymore. It became kind of a legacy. Then who will update it? It can be really painful. And this is where versioning can help. You can decide to version all these web components, also address, payment, and search components. But then you will actually have an extra added governance complexity, because you need something who is maintaining the big portal and who is constantly checking what is the latest version of design system, what is the latest version of address, payment, search, what version of design system are they using? Are we able to upgrade to the latest design system, or are we still waiting for a team? So you can imagine this can be pretty painful as well. So this is what we just shouldn't forget. And we will arrive just to the Angular elements part, where we will see how you can use actually a library from Angular to create web components. You can see that there is an Angular component on the left side. There is Angular elements, which is a library from Angular in the middle, and it will convert your Angular component into a web component. In the end, you will have a bundle.js, and you will be able to download this bundle.js in your host application and simply use a tag name, which you defined earlier, like Angular-component. And then in your host application, your independent Angular component will be rendered, and it will be, it will have the same design, same logic, everything, just you defined using Angular. Let's see this on the code level. How does it look like? First of all, we have to download the Angular Elements library. And after that, we can define the module. This is a web component app module. You can simply skip the declarations, imports, because there is really nothing special, just a regular Angular application. But if you check the line 27, then you will find the key part, because you will see a function called create custom element. Create custom element is the function which is coming from Angular Elements. And this function will be able to create a web component from our regular Angular component. So what we have on this line is called app element. App element is actually a native web standard web component. And on line 29, we are registering this web component into the so-called custom element registry, because this is the way how we can tell the browser that there is a new element, a new tag name. From now on, you can use this in the HTML. So we just registered it. And what we see now, it's a example repository, which I just prepared to showcase how does this work. And I also deployed it to Vercel. Later on, I will also send you the links, and you will be also able to, okay, it's not available, interesting, but I think just the link was bad. Anyway, I prepared it. I will fix the link later. What you see here, we have a main application, which is actually the host. And this host application is using the web component. The web component is everything which is in this cyan or bluish box. And we have also a couple of extra information, couple of extra logic, like we have routing. Routing is always interesting when you are using web components. Here is the higher level routing of the host application itself. We have two simple pages, one simple page with no content and another page where we see the web component. And the web component itself, it also has pages, so you can navigate between the pages of the web component. And what you can see that as we are clicking here and there, here the URL will also be changed. So when I change to the first page, here you see first. And even when I refresh the page, we still see the first page. When I go to the home and I make it to refresh, we are still on the home page. How it was achieved, we will talk about that in a couple of minutes. And what is very important, I also want to talk about it a bit, they are the inputs and outputs. Inputs are things which are actually parameters on the web component. And for example, here the host application is able to generate different random messages which will be consumed in the web component. Let's see what happens if I click on it. For example, it will show hello world, and there are a couple of other variations in different languages. This is how it works. On the other side, the other direction, the web component is also able to send different messages. For example, an example message to the host. And here we see that we just got this message. Let's see how this looks like at the code level. But before we go there, let's talk a bit about the architecture. In this example repository, we are using an NX repository, so it's a monorepo, and we are having two applications. One application is the main application, which is the host, and the other one is the web component application, which we build and serve as a web component using Angular elements. When we are ready with the build process, there will be a main.js file which will be served, or at least local, under the port 4210, and it will be downloaded by the main application. As long as it was downloaded and executed, the main application is able to use this web component -app tag, and the web component will be shown in a completely different application. Okay, let's see how the communication works. We have already seen, let's focus on the bottom part, I mean line 23 and line 24. So we are in the web component part, in the web component app. And this is how we defined a simple input message and a very simple output event for our web component. If we focus now on the bottom part, we see the main application where we are using the web component app. And here we see that we are still able to use the very same syntax for the inputs and outputs, and more or less we react the same as we would we would communicate with a regular Angular component. So nothing special here. Of course, what in the background happens when we are reacting on events, actually native DOM events are thrown. So if we would use another framework, we could also write pure JavaScript event listeners, but in the end, we would get all the details which were emitted in the web component. We also mentioned the routing. It was also an interesting topic because we have the opinion that as long as you are working on a host application with web components, the host application is the only one who should be responsible for handling the URLs. Nobody else should be able to change the URLs, because as soon as it happens, it will lead to chaos. So here is an example. If you navigate to web component host /view, actually the /view part should be kind of recognized from the routing logic in the main application. And then the main application can define this /view as a root parameter for the address web component. Then is the responsibility of the address web component which view will be shown. Will we show the edit site or will we show the view site? And if you have navigation inside of the address web component, when the client navigates to another site, you maybe want to also change the URL. What we said, it's not really recommended to do it directly. So it's a bit better solution if you emit this event and you just tell through an output event that somebody navigated to the /edit. It's your turn, host application, decide what should happen. And here the routing logic will actually change this view part. And this is how the example works, which we have just seen. There are actually just 4 more slides back, so I hope you are still not that tired. Let's see. I wanted to talk about the build process. Just to sum it up very quickly. By default, when we are building an Angular application, we are getting a main.js file, a polyfills.js file, a runtime.js, and the style CSS. Let's see what file is what. Main.js, for example, is the application itself, and runtime.js is the file which is responsible for bootstrapping it, which is responsible for running it. So I would say these are 2 inevitable files which we will need in the host application. It would be nice if we could build them and bundle them together. On the other side, polyfills is something which we do not always need, because if the host application takes care of that, then we don't have to download the polyfills several times. And there is also the style CSS, which is by default the global style sheet. But as long as you are working on self-contained web components, which are responsible for their own styles. You don't need global styles at all. So this is why we need to focus on bundling main.js and runtime.js together, and that's it. Then we will have a bundle.js which can be used to render the web component. This is why we were using an open source library called NGX Build Plus. And it's also something which was developed and maintained by Manfred. And as the result, we get just these 3 files. And in the main.js, we also have the runtime, and we are basically ready. Maybe it's worth to have a look at the Angular.js and what we changed here. As we see, we changed the build process of the web component application. We changed the builder, because from now on, we are using this plugin, NGX Build Plus, and that's it. It will bundle us with this single bundle option through. It will put main.js and runtime.js together. If you have a look at the output path, it can be also interesting, because by default, the web component application would be put next to the main application into the dist apps folder. But we decided to put it under the main application. This is quite reasonable thing if you want to be able to test your host application. So this is kind of a test environment, which I mentioned earlier. And at the same time, it will be also publicly available, your bundle, also for other consumers, if you build it like this. Let's talk just a little bit about package sizes. As long as you are using Angular, you are using not the smallest framework and package in the world. So it has some consequences. And this is the consequence in numbers. Here we see that the main.js is 225 kilobyte, which is actually not that small. And if you take just the core and common libraries, they are about 140 kilobyte from this. And this build is actually this open source example, which I just created to showcase Angular elements. And you know, there's really not much thing in it, not so many components and stuff. So it can grow pretty fast, and you shouldn't forget to keep an eye on these numbers time to time, how a production build looks like. And we just arrived to the summary page. That means we can have a look at it again, what we were talking about. We were talking about the project, how the team looked like, what was the product we had to build, how we initiated the architecture, how a mobile integration looked like, how did we scale with multiple teams later on, what is the vision of micro frontends, what are the benefits, how can we do it, how can we implement it, what are the challenges, why versioning is a kind of a problem. And finally, we have seen an exact example with Angular elements, how we can register web components in the custom element registry. We have seen an example repository. I will also share the link to the repository in a couple of minutes. We were talking about the routing, and we were talking about the build process. So thank you very much. And now it's time for the question and answers. Let's see whether we have questions in this part. And actually we see 2 questions. The first question is, can Angular elements inject services to communicate with other parts of an Angular app, or is that only possible through outputs? Actually, it's possible. This is a very, very interesting thing because you can do that. I would say that you can use Angular services as long as you are in the same bundle. Otherwise, you are isolated and you can't communicate with other services. But you also have access to the global window object. So if we say that is the responsibility of the host application to create a certain API interface or event bus on the window object, then your web component will be able to access it and communicate with this. I hope the question is answered. So now I will just check it. And the next one is, what about calling a remote service from main component? Are the other web components blocked this time? Can multiple service calls happen at the same time? Actually, yes, multiple calls can happen at the same times. They are not blocked. They can communicate independently from each other. But it's also a question, have you meant with remote service? So that's a kind of an HTTP call. Because if you meant an HTTP call, then yes, it's possible. Okay, so I hope we also answered that question. Could a standalone component be wrapped in an Angular element? Any new patterns that could be enabled that way? I don't have a sure answer, but I think that should be possible. So what we have seen in my slides, the code part where we have seen an Angular module, there it should be also possible that you have simply an Angular component which defines its all dependencies, and then maybe there you are. The question is whether you are able to build a component alone. But I think that's a very good question, because I think one module at least we will also need if we are using standalone components, the main module, the highest level module. So I expect that we will have one module and this is what we are able to build in the end. Is it possible to consume Angular elements, build piece in other big frameworks like React or Vue? Absolutely, absolutely. And this is all about that this is 100% framework agnostic. So if you build such a web component using Angular, then you can use it in any HTML site. It doesn't matter which framework is used there. It should be absolutely possible. And with this, we also answered the final question. And I will jump back to the Zoom call, and I will have, yeah, do you have any questions? If you have any questions, you can write in the chat, maybe not related to the presentations, just let us know. Otherwise, I would say that we are finished. Thanks for coming. I hope you found both of the presentations useful. And before you go, I also want to ask, how did you like the presentations? How did you like the meetup in general? And here I have also kind of a questionnaire which I can share with you. You can let us know how likely you would recommend this meetup to other developers. And of course, it's totally fine if you give some low points, but then please be kind and let us know what could we do better, because we really want to improve. At the moment, I have 16 answers out of 27, 17. So that means 62% of the audience took part. Now 18. Let's see whether we can achieve 70%. Right now, okay, with 19, we are right now at 70%. Then I would say that everybody could answer who wanted to answer. Now we have 20 answers. Okay, then I would just end the poll and share the results with you, so you can also have a look at it. We have 21 results in the end. Thank you very much. Maybe the people who rated 7 could write a couple of words, maybe also later. Otherwise, I would say thank you very much. And yeah, have a nice evening, and see you on the next meetup, hopefully. Bye-bye.
Thank you. Bye-bye.
Yeah, thank you. Bye-bye.
Bye-bye.
Bye-bye. Of course, there is time for one last question. This is why I didn't want to close the room, because maybe some of you want to stay here and ask something.
Hey, Marcel. I had one question. I did my hand, but I thought, let me wait. So out of curiosity concerning the project you're working on, and you showed some sheets, it seems like that the projects that you're building are all in the same repository. Is that correct?
Not anymore. Not anymore.
Okay.
Where we did the scaling part, we put everything into different repositories. But actually, it would be also possible to host everything in the same repository. There's nothing against it, but we found it just easier and cleaner to keep everything independent. I can also share my screen. Then I can also show you where it was on the slides. Just
yes, because that makes more sense, because having all the projects in the same repository, but not using module federation and going for web components was a bit weird due to the slides, you know. But I can imagine that way you don't need to worry about having compatible Angular versions if you want to have shared components work with each other and so on.
Exactly. So these are the biggest advantages, that they are really 100% independent. They can even use another framework if they want, and they don't have to care with a huge list of dependencies in the packages, and they have to take care just of the dependencies which they really need, and not the others. So if you have a look at this screen, just a second, I just arrived to that. This is what we had initially. And this is what we had after scaling. So here we have completely different front-end repositories for each of the teams. So these are really clear vertical cuts and no dependencies.
Yeah. We have something similar. The only thing is that we chose for the front end to be a company-wide mono repository. Just to not have, because we do have a lot of shared components, and for not having the burden of versioning, it's it's quite nice. But I understand this choice. And another thing that you didn't mention in your presentation, or maybe I missed it, but I can imagine, because we are running with the same problem. By slicing into domains, you basically are forced to introduce EDA in your landscape. Didn't you have that also?
How do you mean that we have to introduce EDA?
Yeah, event-driven architecture. So you have different components and different slices. For example, if I do something for creating an invoice, but I have another domain that is doing the inventory. They are fully independent. So I was wondering, did you have to do that also at your company?
We didn't have such, or at least I didn't work on such fragments which were part of such problems, but of course, this belongs to one of the biggest kind of challenges of micro frontend. So absolutely, I think we talked about it here, and we mentioned that the communication between fragments and host, and also between certain fragments, can be very exciting, because this is what you mean, right? When in an independent fragment something happens, another fragment should get the info and should react on that.
Yeah, exactly.
Exactly. This is I see two options. As long as you are planning to handle this and take action on the front end, then you have two options. One option is to provide a global event bus, which could be provided by the host application. And then you can define which events are actually possible. Like in your example, you mentioned that you are creating an invoice, right? Or something similar.
Yeah, I gave that as a simple example, yes.
Yeah, then you can define a namespace for the fragment, which is emitting this event, and also some name like create invoice happened, or create invoice event. And on the other hand, all the other fragments which are interested can subscribe on this global event bus. This is one option. But actually, you can also put listeners on the global window object in the document, because as long as no stop propagation will happen, everything should bubble up, and then you should be able to catch these events also in your fragments. But it's pretty important to force good prefixes and all these reasonable output APIs to be defined clearly, what will happen and when, and which fragment requires what. So this is when we arrive to the governance complexity topic again.
Yeah, indeed. Cool.
Good. Any other questions maybe? On how big is your project?
Well, we are like 7 or 8 teams now, and we have quite a lot of a few domains. We are starting up fully new. We had a few monoliths, and it was very hard to continue building on that software. Took forever. And now we are fully splitting from front end to back end into domains. And I think would be 40, 50 domains at least.
Okay, wow, that's nice. It's pretty big.
Yes.
Big challenge. In which industry is your company?
Bookkeeping.
Okay, bookkeeping.
Yeah.
Now I understand your invoice example.
Yeah, it's a simple example, but okay, you can apply it to more things, of course.
Yeah.
But it also has other problems. I think creating slices, at least from my point of view, is that you need full stack developers, but the thing is, a real full stack developer is quite hard to find. Not that someone can't do front end, for example, but it's like a specialism. You're not.
Yeah, absolutely. I think also that it works much better if everybody's specialized. But I think actually no reason why you couldn't do this, because just a second, I try to jump back. Then where we said that we want to scale this and we want to have these vertical slices, we could still use 3 different teams like these. And although I just visualize a full stack developer, but it must not be a full stack developer. It could be also multiple front end and multiple back end developers, because as long as you have this architecture, you can say that, yeah, I have two backend developers who are responsible for the business service, interaction service, and one dedicated front-end developer who is responsible for the web component itself. So there's no reason to restrict yourself just on full stack developers.
No, true. But from a business point of view, what I've seen, and that's not my choice, of course, is that if somebody knows a bit of front end, then it's good enough to start with. And what I personally see in these slices is that it affects the quality of code, mostly in the front end, more than in the back end, because in my company, at least, the devs are more back-end oriented. So that hits the quality of the code.
Okay. Yeah. Okay, I see. Yeah, I know this problem, and I experienced it also in the company where I'm working. Yeah. Then, yeah, the backend developers just say they are full stack, and everybody can work on it.
If it works, then it's good enough, you know.
Yeah. Great. Any other questions from the other participants? If there are no questions, I would say that I will close the channel. And yeah, have a nice evening again.
Yes. Thank you.
Thank you very much. Bye-bye.
Bye-bye.
Ciao.